Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over relationships between your equilibrium constant and the chemical equation. And I'm going to go over some practice problems in this video and some other videos that I'll be shortly doing. So what do I mean by this relationship between K and the chemical reaction? Well, what I mean is that if you change the chemical reaction in some way, that's going to have an effect on the equilibrium constant that you have. Like, so for example, if you reverse the reaction, then that's going to have an effect on the K value of the new reversed reaction. And there's a relationship between the K of the reversed reaction and the K of the original forward reaction. Another thing to keep in mind is if you multiply your equation that you're given by a factor, then you will also have to raise the given K value for the original reaction to the power of whatever factor you multiplied by. So if you multiply your equation by 2, then to get the new K value for your new resulting equation, then you're going to have to raise that K value, the original K value, to the power of 2. You have to square it, right? So these are the relationships that I'm referring to. The other one that's uh, related to Hess's law is that if you have a bunch of reactions, if you have a one reaction that is the resultant of a stepwise other reactions that you add together, then adding those reactions together to get the new K value for that resulting reaction you got from the other reactions that you added together, well, you have to multiply the K values for the reactions you added together to get the K value or the equilibrium constant for your new reaction. So those are a few things. So let's get into this. So here is my original reaction. So if I rewrite that down here, so I have gaseous A in equilibrium with gaseous B, but I have 2B instead of 1B. So the ratio I have 1 to 2. So this is my target reaction. So I'm given the K value. So the K for this reaction is 0.010. So, but my target is this one. So how do I get the K value, my equilibrium constant for this reaction, if I'm given this reaction and its K value? Well, I got to use the relationships between K and the equation. So first thing I notice is that the difference between this one and this one is that it's reversed. Here I have A as a reactant, but here I have A as a product. And here I have B as a product, but here I have B as a reactant. So it's been reversed. So let me reverse this equation. So then I have 2B as a reactant in equilibrium with A as a product. So how do I get the K value for this one? Well, since I reversed it, then what happens is reversing the equation means that I have to take the reciprocal. So I don't know what I said before. I may have misspoke as far as earlier when I talked about reversing the reaction. So reversing the reaction means that my K value is now going to be the reciprocal of that reaction. So since this is my K value, we'll call this K prime. So K prime for this reaction is going to be equal to the reciprocal of the original K. So what does that mean? It would be 1 over K. Since this is K, that means that my new K value for this equation, the equilibrium constant for my new equation is going to be 1 over k, which is going to be 1 over 0.010. And if I calculate that, I think that's 100, but I want to make sure. So 1 divided by 0.01 equals, yep, 100. So my new k value is 100. So, but I'm not done yet because I don't have my target equation yet. So now I notice another thing. I have 2b and I have a here, but here I have b and 1/2 a. So what happens, the difference between here and here is that this equation has been multiplied by 1/2, or everything's been divided by 2 is another way you can think about it, right? But we're multiplying everything by 1/2. So if I multiply this by 1/2, right? Right. So let me write it this way. So I'm going to take my equation here. So, and I'm going to multiply my equation by 1/2. So 2b gas in equilibrium with A gas. So everything here has been multiplied, is being multiplied by 1/2. So if I multiply the 1/2 out throughout everything, so 1/2 times 2b, that's going to be b because the 2's cancel out. So now I have b gas in equilibrium with, and then now the 1/2 here is being multiplied here, which is a 1. 1 times 1/2 is 1/2. So now I have 1/2 a gas. And so now I have the equation that I'm looking for here. So since I had to multiply everything by 1/2 here, now I have to, in order to get my k value, we'll call this k double prime. This k value for this new reaction is going to be equal to this k value, right? My k prime. But now, since I multiplied everything here, I multiplied this equation by 1/2, that means that I'm going to have to raise this to the 1/2 power, right? So it basically, so this is equal to the square root. Maybe I'm jumping ahead of myself. Let me do this step by step. So here's my k prime. That's not a 1, k prime. So I'm going to raise this to the 1/2 power. Because I multiplied everything by 1/2, the power I raise this to is 1/2. So whatever factor I multiply by, that's the factor by which I raise it to a power of. Okay? Now, for those of you who aren't aware of this, 1/2, a power of 1/2 is the same as a square root. So that means that this would be equal to the square root of my k prime. And k prime, we said, was 100. So this would be equal to the square root of 100, which is equal to 10. So my final answer, the equilibrium constant for this reaction here, which is my target reaction, is 10. And that, ladies and gentlemen, is how you figure out your equilibrium constant for one reaction by looking at the relationship of that one reaction, your target reaction, to other known reactions that you have, and see if you can figure out a way in which you can manipulate the equations you're given to get the equation that you want. And therefore, whatever manipulations you do to the equations, you got to do a similar manipulation to your k value to get the new k value. So just to recap what those things are is One, if you reversed your reaction, then the new K value is the reciprocal of the original K value. So you got to do 1 over whatever the K value is. Two, you have to, if you multiply your equation by a factor, then you need to raise the K value. To get the new K value, you need to take the old K value, the original K value, and raise that to the power of whatever factor you multiply by. Okay, so again, in this case, I multiplied by a factor of 1/2, so I had to raise the original K value to a power of 1/2. Okay, and third, if you add equations together to get your target equation, then to find the K value of your target equation, you have to multiply the K values of the equations you added together. And that, ladies and gentlemen, is how it's done. So if you enjoyed this video, if you like the video, if you learned something from this video in any way, shape, or form, then please, by all means, like the video, share the video, hit that like button over there somewhere, and then also make sure you share it with your friends. Make sure that you subscribe to my channel, hit that notification bell, and when you do, make sure you click all, and that way you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.